This is Lesson 5.2, Properties of Exponents and Scientific Notation. Our learning objectives are to simplify expressions using the properties of exponents, use the definition of a negative exponent, and to use scientific notation. So in this lesson, we'll go over 8 different exponent rules, but first let's discuss what exponents represent, right? Exponential notation. In the expression a to the m, the exponent m tells us how many times we use the base a as a factor. So if my base is 2 and my exponent is 3, it looks like this. Well, that exponent 3 tells me how many times to multiply my base 2 together. So I would multiply the base 2 3 times. And so 2 times 2 times 2 would give me 8. 2 to the third power is 8. Another example would be if I had 3 raised to the fourth power. Well, that tells me I need to multiply 3 by itself 4 times. And 3 times 3 times 3 times 3 is 81. Okay, so 3 to the fourth power is 81. So I hope this short explanation has shown you how to use exponential notation. And so now we will move to our first property of exponents, which is the product property. You'll recall product means multiplication in algebra, right? So we're going to use some terms today. We know sum, difference, product, and quotient represent the fancy words of addition, subtraction, multiplication, and division respectively, right? So when I see product property, I think, oh, I'm going to be multiplying these bases with different exponents together. Okay, so here's the official definition. If a is a real number and m and n are integers, then a to the m power times a to the n power equals a to the m plus n power. Okay, so to multiply with like bases, we add the exponents. Here's my everyday kind of quote for you. So if we have the same base, a in this case, we can add their exponents when we're multiplying those bases together. Here's an example, 5.12, to help you make sense of this. So looking here, I see x to the 5th times x to the 9th, and the product rule says I can take the base x and raise it to the 5 plus 9 power. I'm adding the exponents together, and I now have x to the 14th. Okay, so we have simplified. Let's go ahead and try another. Part B, 2 to the 7th times 2 to the 4th, that equals 2 to the 7 plus 4 power, right? We had the same base multiplied, so I could add the exponents. This is the product rule in action. That's 2 to the 11th power. Now, part C increases some complexity here. Now, multiplication is commutative, meaning you can rewrite all of the things that are being multiplied in any order that you want to. If I see this, a lot of times I'll take the 3 times the 4 and the a squared times the a to the 5th to help me see things clearly. Now 3 times 4 is 12, and then I can use the product rule with the same base of a. So I'm going to take a squared and a to the 5th, right, and add their exponents together. That gives me 12 times a to the 7th. Great. And this even works when the bases are fractions. So if I have 5 6 as a fraction squared times 5 6 to the 8th, well, I have multiplication of the same base, so I can add their exponents together to simplify. So here I go. I take 5 6 and I raise that to the 2 plus 8 power, which simplifies to 5 6 to the 10th power. Great, so we can leave it like this. That is the product property, and that is our first property for the day. This is property number 1 that we've learned about. Okay, let's move forward, and we are now going to see a new property called the quotient property. Quotient in algebra means division. All right, so if a is a real number and a does not equal 0, and m and n are integers, then a to the m divided by a to the n equals a to the m minus n. So here's an everyday quote, which will help you make sense of it. To divide with like bases, subtract the exponents. Okay, so if we have the same base a, we can, and there's division between them, we can take their exponents and subtract the top minus the bottom, right? So the top minus the bottom is what we'll do. let's go ahead and look at this, and it will make sense as we practice these 4 quick examples. So when I see x to the 12th divided by x to the 9th, I see like bases, so I could take the top and subtract the bottom. Okay, so x to the 12 minus 9 is x cubed, and there we have it. When I see 5 to the 14th divided by 5 squared, I can turn this into 5 to the 14 minus 2. And so that's 5 to the 12th. When I see 10 to the 8th divided by 10 to the negative 3, I will be very careful because I'll take the base 10 and take the top and subtract the bottom. But I notice subtracting negative 3 is a double negative, so I end up adding them. Okay, so I'll end up adding these together, and that gives me 10 to the 11th power. And now I see q to the 5th divided by q to the negative 4. That's a like base, q. And so I will take the top 5 and subtract the bottom, which is negative 4. Once again, I see this double negative, right? The minus of the formula and the negative of the value. Okay, so I take q and add 5 plus 4, and that gives me 9. So that's q to the 9th power. Great. So we've just gone through our second property today. That is the quotient property. Let's move forward to the next property. The third property we're going to talk about is the zero exponent property. If a is a non-zero number, then a to the 0 equals 1. Now, an everyday quote that'll help you: anything raised to the 0 power is 1. So when we see 10 to the 0 power in this example 5.14, yeah, 10 to the 0 power equals 1. And then when we see something that looks even more complex, like 46 times x squared times y cubed to the 0 power, well, all that stuff is raised to the 0 power, so it equals 1. And that is the zero exponent property. So a lot of students forget about this one. This is a great one to have because it's so simple. Taking any base, raising it to the 0 power, will always equal 1. The only exception is when the base a is 0 itself. Okay, so the only exception is if we had 0 raised to the 0 power. That is undefined. Great, let's go ahead and move forward into our next property. So this next property, our fourth one of the day, is the negative exponent property. So if n is an integer and a does not equal 0, then a to the negative n power equals 1 over a to the positive n power. Or 1 over a to the negative n equals a to the n. Now, let me help you make sense of this. If I have a base with a negative exponent, I can rewrite it as the reciprocal of that. Yeah, 1 over a to the, and then I can change the negative exponent to become positive. This is the same idea, just written as a reciprocal. So if I see 1 over a to the negative n power, I can rewrite that power as a positive power by taking its reciprocal. Okay, let's see this in action in these coming example pieces. So example 5.15, I see a 5 to the negative 2 power. Okay, and so I think, well, I want to make that negative power positive. And so I'll take the reciprocal of 5, which is 1 over 5, and then I can raise that to the positive 2 power. So my answer is 1 over 5 squared. I could rewrite that as 1 over 25 because 5 squared is 25. Let's look at another version of this. If I see 1 over 3 to the negative 4 power, well, I could take its reciprocal, right, to make the exponent positive. And so that becomes 3 to the 4th power, which is 81. When I see 10 to the negative 4 power, well, I could turn that into the reciprocal of 10, which is 1 over 10, and then take that negative and it is now positive. So I make that negative 4 power positive 4 power. And 10 to the fourth power is 10,000. So this could be rewritten if we want as 1 over 10,000. And lastly, when I see 1 over b to the negative 5 power, I could quickly turn that into the reciprocal of 1 over b, which is just b to the 5th power. And I'd leave it like that since my base is a variable. Okay, so you've seen me kind of go back and forth between this version and this version of the negative exponent property. Let's move forward, and we are going to look at a fifth property today. This fifth property is the quotient to a negative exponent property. Okay, so if a and b are real numbers, and a doesn't equal 0 and b doesn't equal 0, and n is an integer, then a over b to the negative n power equals b over a to the positive n power. Okay, so here I've got a quotient, and it's raised to a negative exponent. What I can do to make that negative exponent become positive is I could take the reciprocal of that fraction. Okay, so a over b, taking its reciprocal, becomes b over a. And that negative exponent then became a positive exponent. We never want to have negative exponents in any final solutions. We'll always turn negative exponents into positive exponents. So here's an example of this in action. Example 5.16. I've got 3/5 to the negative 2 power. Well, that equals 5/3 to the positive 2 power. This could be simplified further. When you have a fraction that you square or raise to any power, you could apply that power to the top and bottom of the fraction. So applying to the numerator, we get 5 squared, which is 25, and then divided by 3 squared, which is 9. So this simplifies to 25/9. Now, if I see p over q to the negative 3, I could rewrite that as the reciprocal of p over q, which is q over p. And then I can raise that to the positive 3. And that's going to be as far as I can go since p and q are variables and I don't know their values. All right, so we've just applied the quotient to a negative exponent property. Here we're going to continue to play with negative exponents a little bit more in this next example, 5.17. So if I see 3 to the negative 2 times 3 to the negative 1 times 3 to the fourth, you might remember, hey, we could use the product rule, right? The product rule was the first rule we learned today. So we could add the exponents together since the base is the same in all three cases, 3, 3, and 3. So I could rewrite this as 3 to the negative 2 plus negative 1 plus 4 power. And so that comes out as 3 to the, well, negative 2 minus 1 is negative 3, and negative 3 plus 4 is positive 1. So that comes out as 3 to the first power. And 3 to the first power is just 3. I can make the first power invisible. Whenever I have a power of 1, I can make it invisible. All right, so here's part B. If I see q to the negative 5 times q to the 10th, I could just write that as q to the negative 5 plus 10, and negative 5 plus 10 is positive 5. So this is just simplified to q to the 5th power. All right, moving on to a new property. This is the power property of exponents. So this is the 6th property that you're learning about today. If a is a real number and m and n are integers, then a to the m raised to the n equals a to the m times n. So what's happening is I'm taking a base raised to an exponent, and then I'm applying an exponent to that. And when that occurs, I can take m and multiply it with n. This is called the power property. Okay, so basic phrase, to raise a power to a power, right? To raise a power to a power, multiply the exponents together. So here are some examples of this in action. Example 5.18, y to the 5th raised to the 9th. That's the same thing as y to the 5 times 9. And 5 times 9 is 45. So this is y to the 45th power. When I see 4 to the 4th raised to the 7th, I take my base of 4 and I multiply the exponents of 4 and 7 together. And 4 times 7 is 28. So this is 4 to the 28th power. When I see k cubed raised to the z, right? K is the base and it's cubed, and that's all raised to the z power. I can write that as k to the 3 times z power. Okay, and we've got some variables here and things don't simplify any further. This is k raised to the 3 times z power. All right, we are moving on to the next property, number 7. That's the power of a product property. And it says if a and b are real numbers and m is a whole number, then a times b to the m equals a to the m times b to the m. Meaning if I have two things that are being multiplied together, right, the product of two things, and I raise a power to it, then I can apply that power to both bases, a and b. Okay, so a times b raised to the m power equals a to the m times b to the m. Okay, so let's go ahead and see this power of a product property in action. If I see 3 times x to the 5th power, I can rewrite that as 3 to the 5th times x to the 5th. I've applied the exponent 5 to both bases, 3 and x. This can only happen when you have multiplication or division between terms, okay? Multiplication and division between two factors. Let's try another one. 6 times k to the 5th. Well, that's just 6 to the 5th times k to the 5th. When I see negative 4 times a to the 4th times b, I see three bases. I see the base negative 4 multiplied with the base a multiplied with the base b. So this second power can be applied to all of the bases. And so let's write that out. Well, that would be negative 4 squared, okay, times a to the 4th squared times b squared. Okay, and we can clean that up a little bit. So that becomes, well, negative 4 times itself is 16. And then a to the 4th squared, we can use the power property of multiplying these together. And I get a to the 8th. Okay, so a to the 8th. And then b squared is just b squared. So the result is 16 times a to the 8th times b squared. Let's try another one, making sure that we've got this down. So I see 5 times x times y to the negative 3, and that's all raised to the 3rd power. So I'm going to apply the 3rd power to all of the bases using this power of a product property. Okay, so I've got 5 cubed times x cubed times y to the negative 3 cubed. And now cleaning this up a little bit, 5 cubed is 5 times 5 times 5, which is 125. And then I've got this x cubed. And then y to the negative 3 times 3, right? I'm going to multiply these together using the power rule, and I get y to the negative 9. Okay, and at this point, I do not want to have a negative exponent as a result. And so we'll take this just one step further, and we'll write it as 125 times x to the 3rd divided by y to the 9th. So what I did was I took the reciprocal of y to the negative 9 to turn it into y to the positive 9. But in doing so, that went into the denominator of this expression, right? So this becomes 125 times x cubed divided by y to the 9th because I wanted to make that negative exponent become positive using the negative exponent rule that we learned up here. Great. Next, we have an eighth property, the power of a quotient property. This is number 8. And it's very similar to this one we did up here, the power of a product property. But instead of multiplying bases together, we're going to see that we're dividing bases. Okay, so if a and b are real numbers and b does not equal 0, m is a counting number, then a over b to the m equals a to the m over b to the m, meaning I can apply the exponent to the numerator and denominator of a fraction. Here's an everyday phrase. To raise a fraction to a power, raise the numerator and denominator to that power. Okay, so that's the rule. Let's go ahead and look at an example of this rule in action. So example 5.20 says simplify each expression. I've got 2/3 to the 5th power. Well, that's equal to 2 to the 5th divided by 3 to the 5th, according to this quotient of a power property. Power of a quotient, I should say. Power of a quotient property. Okay, so looking at another example of this, if I saw u over v to the 4th, I could write that as u to the 4th divided by v to the 4th. If I see x to the -3 divided by y to the -5 to the 4th, okay, what I can do is I could take that stuff. I don't like having negative exponents. And how do I get rid of negative exponents? Take the reciprocal. So this would move to the top and it becomes y to the +5. This would move to the bottom. It becomes x to the +3. And this could be good to do first, since we don't want to have any negative answers in our results. I'll rewrite it as y to the 5th over x cubed, and that's raised to the 4th. And now let's apply the 4th power to the top and bottom of this. So I get y to the 20th, right? Because 5 times 4 is 20, divided by x to the 12th, since 3 times 4 is 12. All right? So there you go. That's my final result that I will report. It's simplified as far as possible. Y to the 20th divided by x to the 12th. And now let's go for something that looks even more complicated. Here's part D. It says 3 times a to the -2 times b cubed divided by c to the -4 all cubed. All right. So the first thing you could think to do is get rid of the negative exponents by taking the reciprocals. So anything that's on the top goes to the bottom and becomes the positive exponent, and anything that's on bottom goes to the top and becomes a positive exponent. So I would rewrite this as 3 times c to the 4th times b cubed divided by a squared, and then all of that is cubed. You see, I took a to the -2, I moved it to the bottom, and it became a squared. C to the -4, I moved it to the top, and it became c to the +4. Now, I can apply this exponent to all of the bases of the fraction. So this will be 3 cubed, and c to the 4th cubed, and b cubed cubed, divided by a squared cubed. All right, so cleaning this up, it looks like this. Well, 3 cubed is 27. C to the 4th cubed is c to the 12th, because I'm multiplying their exponents together, 4 times 3. Okay, and then b cubed cubed is b to the 9th. I'm multiplying 3 times 3 to get the new exponent of 9. And then I divide that by a squared cubed. So 2 times 3 gives me 6. I've got a to the 6th power. There I go. And this is as far as I can take it. And in fact, I'll drop the parentheses since I've applied the exterior exponent to it. Okay, and then that's my final result. Let's go ahead and play with all of the exponent rules that we've learned. Now, reminder, we've gone through, wow, 8 different exponent rules, and you need to be very confident with all of these exponent rules moving forward in this course and beyond this course. So I highly suggest taking the time to drill yourself. Do you know these 8 rules that we've learned about today, these properties of exponents? And you'll see that we don't just use one property at a time. You've already started to see that in some of these examples. We're using multiple properties at one time to simplify as far as we can. So let's try applying a lot of properties at the same time. Here's example 5.21, and I see 3 times x squared times y raised to the fourth times 2 times x times y squared cubed. Okay, and we think, how would we simplify this? Well, I see some different properties here at play, including the power of a product rule, right? The power of a product and power of a product again. So let's start by cleaning that up. And so I would take 3 and raise it to the fourth times x squared raised to the fourth, which is multiplying the exponents together, and then y to the fourth. Okay, so I've applied this exponent of 4 to this base, this, and this. Okay, and you see it there. And now I'm going to do the same thing with this exponent of 3, applying it to 2x and y squared. And I get 2 cubed, and I get x cubed, and I get y squared cubed, which I will multiply their bases, their exponents together. Okay, so here I am at this point, and so maybe I start to organize this a little more. Like, this is all just multiplying of these bases together. And 3 to the fourth is 81, and x to the 2 times 4 is x to the 8th, and then I have the y to the 4th, and then 2 cubed is 8, and then x cubed, and then y to the 6th, because 2 times 3 is 6th. And so I'm just multiplying all these pieces together. And I could reorganize these if I want to. So we could put all of the numbers together, like 81 times 8, and then x to the 8th times x cubed, and then the y terms together, like y to the 4th times y to the 6th. Okay, and I see the product property, right? If I have the same base with multiplication between, I could add the exponents together. And also for the same base y, I could add their exponents together. And then I could multiply 81 times 8 together, okay? And so 81 times 8 gives me 648. And then x to the 8th times x cubed gives me x to the 8 plus 3, which is x to the 11th. And y to the 4 times y to the 6 gives me y to the 4 plus 6, which is 10. There we go. So we have simplified this fully. Well, let's try another. So in this case, part B, I see different rules. Like I see the power rule, I see negative exponent rule, I see the quotient rule, okay, and I see the power rule again. And what your goal is to clean this up little by little. And to be honest, there are many different approaches you could take, and you could come to the same answer as I do. There are different pathways to get to the answer. Whatever we decide to apply first, just make sure to be consistent. Okay, so if I see this, I might start to clean things up by applying the power rule. So I'll take x to the 3 times 4. Okay, so I'm going to multiply those exponents together to get x to the 12th. And then I'll multiply then x to the negative 2 times 5, and that gives me x to the negative 10 power. And then I divide by, well, x to the 6 times 5, which is x to the, well, 6 times 5 is 30. And so I've applied the power rule, and now I start to maybe apply the product rule to the top. So if I see x to the 12th times x to the negative 10, I could add their exponents together to combine the same base into 1. So I'll rewrite this as x to the 12 plus negative 10, but 12 plus negative 10 is 2. That's divided by x to the 30th. And now I see a quotient rule, right? I see the same base, the top and bottom. So I could take the top and subtract the bottom. And so I might write this as x to the 2 minus 30. But 2 minus 30 is negative 28. Okay, so I'll write 2 minus 30 as negative 28. And then I don't like to have a negative exponent in the answer. In fact, you're not allowed to have a negative exponent in the answer for any of your assignments or tests. So if you end up with this, you can rewrite it as the reciprocal, right? The reciprocal of x to the negative 28 is x 1 over x to the positive 28. So we made the negative exponent become positive by taking the reciprocal. Great. And now let's address this part C right here. So we see a lot going on in these expressions, but it can be simplified. Our goal is to simplify this. So we just start digging in and seeing what we can accomplish. So looking at this, something that we could do is we could make the negative exponents become positive by putting this stuff up in the top. Right? This base with a negative exponent, I could flip it to the top. This base with a negative exponent, I could flip it into the top. So I'll rewrite this as 2xy squared, and then another y squared divided by x cubed. And that's all squared. So what I've done is I've taken this y to the negative 2, I put it into the top, so it became y to the positive 2. Right? We're getting rid of negative exponents. That's something I'm observing I can do right away. And if I do that here, I would have 12xy cubed times y to the first, right? So I'm going to flip that to the top. And that's divided by, all I have in the bottom is x cubed. And that's raised all to the negative 1. Well, at this point, I can apply the powers that I see, like this second power here. So I'll apply that to all of the bases that I have in this expression inside. So that's 2 squared times x squared times y squared squared, okay, which becomes a y to the 2 times 2. And then another y to the 2 times 2. And that's divided by x cubed squared, which is x to the 3 times 2. Great. Now, applying this negative 1 power, well, wouldn't that just flip the top and bottom? So we take the reciprocal of this, and then that makes it so that this becomes a positive 1. That was one of our rules that we discussed. So we can do that. We could multiply by x cubed on top divided by 12x y cubed y. Okay, so we just took the reciprocal of this fraction because we applied that negative 1 exponent. Okay, so we put the denominator in the numerator and the numerator in the denominator. That's the reciprocal, and so we just applied that rule. Okay, time to clean this up even further. So what I would do is I would just start to simplify as much as possible. Okay, and seeing 2 squared, I could turn 2 squared into 4. Right, this 2 squared becomes 4. And then this x squared, I'll just keep it as x squared for now. And then this y to the 2 times 2 becomes y to the 4th. And this y to the 2 times 2 becomes y to the 4th. And y to the 4th times y to the 4th is y to the 4 plus 4, which is y to the 8th. And then in the bottom, I have x to the 3 times 2. Okay, so that's x to the 6th. And then I still have the multiplication by x cubed divided by that bottom 12 times x times y to the fourth. Because I could take the y cubed times y to the first and add the exponents of 3 plus 1 together and get 4. Great. We've made it to this point. And the goal is still to simplify. In fact, you could start to think, how can I simplify this further? Well, we could take the x squared and the x cubed and add them together since there's multiplication between them. So these pieces can become, well, x to the fifth, right? 4 times x to the fifth times y to the eighth. And then on bottom, combining pieces together, I see x to the sixth and x to the first, multiplication between them. So I could turn that into x to the sixth plus 1. So here I've got 12 times x to the seventh times y to the fourth. And to simplify things just a little further, this 4 over 12 reduces to 1/3. Okay, so I could rewrite this as 1/3 because that's 4 out of 12 that reduces. And then I could use the quotient rule saying, hey, I've got x to the fifth divided by x to the seventh. And one cool trick is to say how many more x's are on bottom than on top. Well, here I have 5 x's. Here I have 7 x's. There are 2 more x's on bottom than on top. So I could put an x squared on the bottom. And you could do the same thing with y's. How many more y's are on top than on bottom? Well, there are 4 more y's on top than on bottom because that's 8 and 4. So there's 4 more y's on top than on bottom. So that would be y to the fourth. And 1 times y to the fourth is just y to the fourth. So I can make that 1 multiplication invisible. And this is the final result. We have simplified this all the way. Great. Now, we have just used a lot of rules, properties of exponents to simplify this thing that we saw right here into this result here. Okay, and sometimes it takes a lot of thought. I went through a process that took me from here to here to here to here to here. You could have gone through a different process, applying things in a different order than I did. And as long as you stayed consistent, we would have had the same result. We're going to finish this lesson today talking about using scientific notation. Okay, so how do you write a number in scientific notation? Well, step 1, move the decimal point so that the first digit is greater than or equal to 1, but less than 10. Step 2, count the number of decimal places n that the decimal point has moved. Step 3, write the number as a product with a power of 10. If the number is greater than or equal to 1, the power of 10 will be 10 to the n. But if it's between 0 and 1, then the power of 10 will be 10 to the negative n. This will take on meaning as we look at example 5.22, and it says write scientific notation for 37,000 and for 0.0052. Great. Well, here's how scientific notation works. We move a decimal place, and here's the decimal place in this case, until it goes after the first significant figure. Okay, so a significant figure is the first number that's not a 0 that appears. So I see the 3 is the first number. It's not a 0. So I have to move the decimal place that's currently right here over a certain amount of spaces. I suggest taking and just putting little bumps along the way to try to get from your first spot to your last spot. You see? And so you count how many places you had to move the digit, in this case to the left, and we can rewrite our number at 37,000 as 3.7 times 10 to the fourth power. Why do I say the fourth power? Because I move my decimal place 1, 2, 3, 4 places to the left. All right. So rewriting 37,000 in scientific notation becomes 3.7 times 10 to the fourth. The decimal place always goes after the first significant figure. Sometimes, instead of moving the decimal to the left a certain amount of places, we have to move the decimal a certain amount of places to the right. So here's part B of this example. And here's my current decimal place location. And I want to move it after the first sig fig. the first significant figure is 5, right? Because every number before you get to 5 is a 0. There's the first number that's not a 0. That's the first significant figure. That's where we want to put the decimal place. And then we ask, how many places do I have to move the decimal to get there? Well, I had to move it 3 decimal places to the right. And so I will write my answer in scientific notation as 5.2 times 10 to the negative 3 power. Why did I write a negative exponent? Because I had to move my decimal to the right. When I moved it to the left, I had a positive exponent. When I move it to the right, that gives me a negative exponent as a result. Okay, so I have just written 0.0052 as 5.2 times 10 to the negative 3 power in exponential notation, scientific notation. All right, so we just went from a normal number into scientific notation. How do I convert back? Okay, so how to convert from scientific notation to decimal form? Well, step 1, determine the exponent n on the factor of 10. Step 2, move the decimal n places, adding zeros if needed. Now, if the exponent is positive, move the decimal point n places to the right. If the exponent is negative, move the decimal place, the absolute value of n places to the left. Let's see this in action. So we want to take this number that's in scientific notation and convert it to decimal form, like normal number form. Okay? And so I see 1.3 times 10 to the fourth. Well, I would take 1.3 and move the decimal place 4 places to the right. Okay, so you can do this. 1, 2, 3, 4. This is where the new decimal goes. Any blank spaces, fill it with zeros. Okay, so we now know that this number, 1.3 times 10 to the fourth, is 13,000. That's what it is. The exponent tells me how many places to move the decimal to the right in this case because it's positive. But if the exponent is negative, then we would be moving the decimal to the left. All right? So 7.5 times 10 to the negative 10, that's a really small number. What we'll do is we'll write 7.5, and then we will create spaces for moving the decimal 10 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my decimal is all the way over here, and I fill in the spaces with zeros, and that is my number. So 7.5 times 10 to the negative 10 power, well, that's 0.0000000075. It's a very small number. Okay, that is decimal form for that value. I hope this has been helpful. We have just practiced converting from decimal form to scientific notation and scientific notation to decimal form. And you can now make those conversions happen. Now, sometimes we take things that are in scientific notation and we multiply them together. Two things in scientific notation, we can multiply them together. We could also take two things in scientific notation and divide them. So this is our final example for this lesson. Here in example 5.24, we will multiply 3 times 10 to the negative 2 times 8 times 10 to the negative 6. And to do it, a good way to get this done is to take 3 times 8, right, times 10 to the negative 2 times 10 to the negative 6. So I'm reorganizing these things so that these numbers go together, 3 times 8, and then times 10 to the negative 2 times 10 to the negative 6. But this is just the product rule of exponents that we've learned. Yeah? So 3 times 8 is 24. Okay? And then that's multiplied by 10 to the negative 8, right? Because I can add negative 2 plus negative 6, adding them together gives me negative 8. I've just used the product rule of exponents. Now, this is not quite in decimal form yet, so we need to put it in decimal form. And to get that done, we just need to move the decimal place of 24, well, 8 places to the left, right? So this is 10 to the negative 8. I need to move this 24 8 decimal places to the left. I'll do this up above. So taking 24, okay, and moving the decimal 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. My new decimal goes there, and I fill everything in with zeros. There you have it. And so that is my result. I'll just get rid of this stuff underneath it, and I will show that that's the answer. 0.00000024. Great, we just multiplied these two things in scientific notation together. Now, we could do the same thing with division. Okay, so we can take the top and divide the bottom. Well, 9 divided by 3 we can do. Okay, and that just becomes 3. And then we could use the quotient rule, 10 to the third divided by 10 to the negative 3. Careful, that's going to be 10 to the 3 minus negative 3. And so that becomes a plus. Okay, so this whole thing becomes 3 times 10 to the 6th. Now, we need to move the decimal, right, which is currently right here. It's like 3.0 times 10 to the 6th. We need to move the decimal 6 places to the right, because this is a bigger number than 3. So I take that 3 point and I move it 1, 2, 3, 4, 5, 6 places to the right, and I fill in all the zeros like that. And now my decimal is all the way to there. Okay, so what is that? That is actually 3 million. Okay, so my decimal place got to right there. I'm going to make it invisible. This is a nice clean number, 3 million. 3 times 10 to the 6th is 3 million. Great. So here has been an introduction to scientific notation and how to put things from scientific notation into decimal form into scientific notation, and how to multiply two things in scientific notation together, and how to divide two things in scientific notation from each other. I hope you have a wonderful day. Thank you.